one of the very interesting things that you can play with at the beginning to analyze the images is especially when you have data that evolves over time, is to actually use the temporal dimension for filtering and processing, which a lot of the times as a beginner you don't play with. All right. So what we're gonna try is that we go into EMBL, we're gonna go into samples, and then there is a data set which is quite nice to exemplify this, which is called listeria, if I remember right. Yes, listeria cells here. Boom. So we are gonna open those. Right, and then what you're seeing here is that you see how these objects move over time. And for example, if we would like to track these objects, that would be a very interesting scientific question, but because of the presence of the background, it's a little bit challenging, right? So how do we make this sort of easier for us to follow, or by other algorithms to then track these objects? So what we're going to do is that we are going to try to remove that background that is kind of making the image more challenging. So one of the first things that you can do is that you can use set, what is called in FIJI set projections, right? I can already see here that my language is not correct. So set project. Okay, so you see plugins, stack, set projections, and I see run. And then here you have different options, and a good alternative in this case is to ask for a median projection. That is going to take a particular pixel, look at it over time, and calculate the median value. So we say OK, and then you see that this is the median value of each pixel over the time frame. All right, and as you see, the objects that were moving are not there anymore because at some point the object was present in this pixel, but then it moved away. So when you calculate the median, it's not there anymore. So a median has a property over time to mainly show you the constant background and not the objects that were moving. Okay, so then the next thing that we can do if we want to perhaps remove a little bit some of the fine structure in this background is that we can again use a Gaussian filter. Then, for example, I can see what happens with a Gaussian blur of radius 5. Let's say that that is okay. And now I have something that resembles my background. Then finally, what I can do is the image calculator. So I can look for calculator, image calculator. Then what I'm going to do is I'm going to take my original data and I'm going to subtract my median filtered. I'm going to create a new window. So in case that I don't lose anything if I made a mistake, and very important, I'm going to create a 32-bit float because sometimes the pixels values might become negative now because of the subtraction. So I say, okay. It asks me, do you want to process all images? I say yes, because I have a single background for all my images. And then I get this result over here. All right. And then you will see now if I play this movie that the features that we're interested in are much more enhanced against the background. Right. Now, another feature that you will see if I play this movie very quickly is that the background subtraction worked much better at the end than at the beginning. And this is probably because we also have a background that is bleaching. Right, so that we could correct for later on with a little bit more advanced methods, but this gives you an idea. Now, what we could do is that we can then run this other command that is called temporal color code. And then I can say, okay, what LUT to use, what is the range, and I say, okay. And now what we take is this is in a time frame, and this shows you how your objects were moving over time, right? So blue is the beginning of the frame, red is the end of the frame. And this you could use to then trace back the movement of your objects. Okay, it's a nice representation of the data. Now, another alternative, something which is also very convenient, is to calculate the difference between frames that are spaced in time. So I think this is called stack difference. Okay, I'm gonna run that. And then I need to tell the gap between the frames. And this depends actually on the speed of your object. So you can play with this, but let's use a speed of around 5. So that is, I'm calculating the differences between the image right now and 5 time points before me. I run that, and then you end up with this new stack that you will see that is smaller because of this 5 frame window that we have to look at. And then I can do again image, adjust brightness and contrast. We can adjust a little bit more. Let's not exaggerate it, but just so you see how much the background was completely removed, and the only thing that is present there is the objects that move. Okay, so this is a very, very beautiful now enhanced image of the moving objects. And now if I were to now do again this color-coded projection. So if I look for the word code, I find it, and I run it. I say okay. Now again, this is the same, very similar time frame, a little bit different because I have removed a few frames, right? But now you get this data, and we can compare that with this one. And now what you see is that, of course, the background here was completely suppressed, basically, and it's much easier to now track my objects if that's what we're interested in.